Electrodegradation, which also known as electrochemical degradations, is an effective and environmental sustainable technique for treating harmful substances in water and wastewater, such as dyes. Dyes which come from large-scale productions and countless applications of colorants in manufacturing industry, which will produce serious environmental water problems which lead to health risks. This process uses electrical energy to drive chemical reactions at the electrode surface, which helps to break down the pollutants such as dye into simpler, less harmful, or inert byproducts. As a result, electrode degradations offer an efficient and green way to remove dyes from contaminated water, and it improves water quality. In this respective experiment, the dye which is the methylene blue will be used. Methylene blue is a cation dye that is difficult to degrade in natural process, which have the potential to disrupt ecological systems. Methylene blue will undergo a rapid reaction with OH radical, follow the formal hydrogen transfers and radical adduct formation mechanisms, which will break into smaller intermediates like carbon dioxide and water by the highly reactive OH radical.
These are the few objectives we aim to achieve through our project. Firstly, we plan to demonstrate a simple electrodegradation setup by using graphite electrodes and low power supply. Second, we aim to determine the effectiveness of electrodegradation in removing color dye, which is methylene blue, from the contaminated water. And last but not least, we hope to enhance awareness about water pollution and sustainability among the youth to protect the local environment. Our target group for this project is the secondary school students, specifically the Form 2 students from SMK Sri Muda, Penaga in Seberang Perai Utara Penang. Through this activity, we hope to spark their interest in science and encourage them to care and protect our environment. For this project, we will be using a few simple materials, such as three 250 ml beakers, a methylene blue dye contaminated water sample, and a sodium bicarbonate solution as the electrolyte. We also used a 9-volt direct current power supply, two graphite electrodes, and connecting wires with alligator clips to set up the circuit. And finally, we will use a stirring rod and some clips or tape to hold everything in place.
Now I'm going to explain the implementation method of our project. Firstly, the dye-contaminated water with methylene blue is added into a 100 ml sodium bicarbonate solution, which acts as an electrolyte. Next, pour 100 ml of dye-contaminated water into the beaker. Insert both graphite electrodes about 3 cm apart in the solution as shown in the figure. Then connect the electrode to a 9-volt battery using alligator clips. The positive clips to one electrode, which is anode, and the negative clip to another one, which is cathode. After the apparatus is set up, turn on the power and start the stopwatch. Next, observe reaction change, bubbling, color fading, and flux formation. Gently stir after 5 minutes to enhance mixing. Disconnect power after 8 minutes and let the water stand and observe the sediment formation. And lastly, record the result in the report sheet. The report sheet consists of 3 parts. In part A, students need to record their observation of color intensity, bubbles, and flux in the table. Next, in part B, the color chart is provided for the students to compare the color change during the experiment. And lastly, the summary part is for the student to summarize their observation for the whole experiment.
So consequently, the color of the solution will fade quickly as the dye molecules are oxidized and degraded through hydroxyl radicals and direct electron transfer. During the reaction, there are only gas bubbles, mainly oxygen and hydrogen, generated at the electrode, as graphite electrodes are in it. In this experiment, the graphite electrode act as a conductive surfaces. Thus, there will be no coagulants formed at the electrode in state of degradation. As a result, the water that is treated will become visibly clearer. So, what will students learn through this SULAM project? They will gain both scientific understanding and practical skills. They will not only be clear that electricity can be used to treat and clean polluted water through simple chemical reactions, but also inculcate the awareness of being environment-friendly into them. In conclusion, this hands-on activity through the SULAM project encourages the curiosity in how to use science and technology to benefit and conserve the water resources, as well as having the awareness in protecting the environment from being destroyed. Thank you.